Hello there, welcome to our little shop, and today we've got something entirely different. I'm carrying on with my invasion of the British amps here, and this one fits right in because, well, we got a red coat coming. So anyway, for you that do not know what this is a model Mercury Marshall. They were made only for mail order. They usually came in orange or red, and this one's red. Like I say, one EL84, solid state front end, one 12-inch speaker. The speaker is out of this one at the current time. That's a whole nother story as part of this repair. It's at my speaker bench at home, trying to find parts for it. So anyway, moving along. Customer brought this in. He had just acquired it from across the pond. He was trying to get it to operate here. It seemed to be very lacking in wattage, he seemed to think, which was pretty good summation, simply because the speaker was an 8 ohm speaker that was in it instead of the 4. When I actually measured the wattage at 8 ohms with this, he's getting 2.5 watts out of it. And another problem was, there's his plug. Okay? Which meant he had to use this to run it. So he wanted to get rid of that and get it converted to run on our voltage. Second situation, when he got the amplifier, it came with the original fried power transformer. Which didn't do any good except for having the original transformer with it. So what we're going to do is replace the transformer. And yes, I'm using a Mercury. Seems to be the right call, huh? Actually, there's not a whole lot of direct replacement transformers out there for this amp. The transformer that's in it right now is a very low priced transformer. I think it may be out of a Marshall Class 5. So we're going to deal with that. I'll give you an AC cable on it. But anyway, that gets you caught up to this point. I'm going to tear this open and get with it. Alright, well, it's been about an hour and a half. I have the new AC cable on. I have the new power transformer in. I have gotten rid of the faux center tap that they used on the heater, the two 100 ohm resistors to ground, because the correct transformer has a center tap that's meant to go to the board. So those just went in the garbage. Anyway, so we got rid of a few more things. We got rid of this. Anyway, so what we're into now, we're checking out why this thing was running so hot. I actually have a new tube in it just to rule out any other possibilities. And we have a whopping 276 volt power supply, which, you know, about 350 is really about max for an EL84. So anyway, we've got 276.5 volts. We have a cathode voltage of 6.6. So if you take the cathode voltage from the plate voltage, they give you 269.9, which I'm going to call 270. Now, here's the story. We're drawing about 60 milliamps over here on this EL84. Full plate dissipation should be about 45 mils. So we need to find out where our culprit is. is the culprit the cathode resistor, as most people would think, or is the culprit the screen current? We'll find out. This is going to be a little tricky because we have a circuit board to deal with, and disconnecting the screen is going to be a problem. Or disconnecting the cathode could be a problem. So let's see how this shakes out. But we need to get this down about 45 mils. Alright, well, we found a sneaky way to do this. We dropped the screen power supply resistor one end from the board and hooked onto it. Hooked the other end onto the screen and put our little meter in between it. So what we've got here, this is our plate current meter, this is our screen meter, these are our voltages. I have my tube manual, my schematic, my calculator, and my scribble pad, scrap paper. So anyway, so here's what we've come up with, and you can look at the numbers right here. One of the problems is our screen voltage is higher than the plate voltage. Never a good thing. So it's actually 280 volts. Our plate is roughly 270. So we're looking at a 10 volt difference. Not good. Like I said earlier, we're drawing 60 mils through the plate. Our screen right now at idle is drawing 8 mils, actually 8.4. Normal dissipation for the screen by calculations of that voltage should be 7 mils, but even more interesting is maximum plate dissipation for that screen with signal. At this point should be 14 mils, and we've got 18. Like I say, this tube needs to come down some. So I think we're going to start with dropping the screen supply resistor. It already has a 1K screen resistor, so that's good there. So let's drop the power supply, get that voltage down. So I thought we better take a minute here to clarify something. I had mentioned that we had a 1K screen resistor, but here's what the deal is. Our power supply comes in here at this side of the transformer. This is your output transformer. So your high voltage comes in here, roughly your 270-ish volts. It goes through this 1K resistor, a filter cap, and this becomes your screen voltage. It comes up here to another 1K resistor. Now this is actually your screen resistor I was speaking of. This is your dropping resistor to drop the voltage from your high voltage to your screen voltage. Like I say, it's a 1K. It's the one that we're going to change. Then this 27K will remain the same. It goes up and feeds your low voltage to your transistors. So there, heading off a few questions. Alright, let's get you caught up. I've been doing some tweaking and playing around here, and what we have got now is we have dropped our screen voltage quite a bit. And our plate voltage has gone up because of that, because our plate current has gone down. Our plate current has gone from 60 mils to 46. I was shooting for about 45 on the plate, so I'm happy with that. The screen I've gotten down to where I have it below the 2 watt dissipation and well below the 4 absolute maximum. We actually are drawing 6.7 mils at idle now, and the 2 watt limit is 7, so we're pretty cool right there. And when we max this out, we now get 9.7 mils instead of like 18. Another side benefit for you, let's look over here. That is full clean volume that I measured at about 4.6 watts clean. There's max. Hang on, I'll get a number for you. Okay, what we've got there is max wattage is 6.5 watts. So max is 6.5, dropping down to about there is 4.6. When? So what happened is, this works just almost every time out this way. I took the 1K resistor out for the screen supply and worked my way up to a 10K, which works just fine. Gets everything within limits. Happy tubes. Well, happy tube. So it's running much lower than it was. Like I say, it's get the signal off this. $47 mils. Well, we have changed locations on you. I'm at my laboratory here, and this little table, a lot of cool stuff happens. Right here we actually have a couple Celestion G12Ms ready to be reconed. Here's a couple, well, half dozen of my little speaker motors ready to be assembled. That's for the guys that think that I really don't make my own speakers. So, you know, take a good look. Anyway, so, but the real story here is this little guy right here. This is the speaker for the Marshall Mercury. This is what came in it. It's obviously an English speaker. The terminal strip here actually is exactly like on the Celestions here. It's definitely an English speaker. I'm thinking it's either a Celestion or a Goodman. The problem is there was no numbers on it anywhere. The only number on it was on the gasket that I salvaged. So anyway, after several hours spread over several evenings of hunting parts for this, we've actually come up with stuff that I believe fits properly. The original speaker was 8 ohms, and the cone had been damaged anyway. So, but the 8 ohms is a problem. The output transformer is meant to have a 4 ohm load on it. So I hunted and I hunted and I hunted. The voice coil diameter is a weird size. It's 0.998 inside diameter. I actually found one that was exactly 1 inch in the listings that the specs matched perfectly. The coil height, the coil resistance, the number of windings. The only difference is the height of the form, which is not a problem. The cone, surprisingly, we had tried to find a cone for it and had given up on finding a cone, but as it turned out, a cone for a Jensen P10R is almost identical. I was going by the heights, and it was showing to be about a 1/16 of an inch too high. Well, there's a trick to that. All the English speakers, the spider sets down on the neck of the cone, so you actually lose a little height there. So that worked out perfectly. So I'm ready to start gluing these speakers up here. Like I say, this little guy's been a little bit of a nuisance, but people don't realize what we actually go through trying to solve problems for owners. But anyway, we're going to glue this little guy up. I think we've got it whipped. There's a couple little things. The gasket is a little thinner than I would like to see. I may make a little spacer to go on it. We'll see. We'll see what happens. It's a very fluid situation at the time. So speaking of fluid, my epoxy is just about ready to be used. At the temperature we have down here, it's about 77 degrees in here, very low humidity, but this epoxy that usually is about a 15-hour cure epoxy is probably going to cure in about 4 to 5 hours. So I'm going to get with it and start gluing some speakers together. So I'll catch you up later. Okay, well, let's take a minute to get you caught up briefly. The epoxy set up on these fairly quick. It took about 6 hours. So last evening I went ahead and glued the cone and suspension in. The spider and all that's taken care of. So this speaker at this point is at the point where you test it to find out whether what you have done is going to work out or whether you've got to start over. I've pulled my shim stock out of it. The cone is loose and free. Sorry, I can't use both hands. I'm holding the camera. So anyway, cone is loose and free. There's no voice coil rubs. So we're ready to continue on, which our next step is to put the lead wires on and test the speaker before we do the gasket and dust cover. The dust cover is going to be different than the original. We're going to be using a slightly larger Celestian style screen dust cover, so we'll have to fit that. The other speakers, I have not glued the cones and stuff in yet. Of course, those haven't had anything done. But this is our main priority. It's Sunday evening, about 7:30. The other stuff I did yesterday. And I want to get the leads on this one and possibly get this speaker finished up to take back to the shop tomorrow. So it's either going to be finished in the morning or tomorrow night. Well, there we go. We have our little mystery speaker completed. It works fine. Been tested out. I've glued the gasket back on, the dust cover, done the wiring on it. We're all good. Let this dry overnight. It goes across town to the shop tomorrow. And I can put this little Marshall Mercury job to bed. Get it off the bench and out of the shop. Well, well, well. This is a disturbing new development. We have a hum issue that I didn't notice before. Doesn't really matter where the volume control is. And it gets better when you turn the tone control up. So, guess we're going to take this back apart again. But I was looking down here, and our tone control is set up really weird. It's like a balance control. We've got highs on one side, we've got lows on the other side, and you pan between it. Thanks, Jim. Let's see what we can do about this. Well, we're back in this little Marshall. And I believe I have most of the problems taken care of here with this hum. I love when things are designed in. Basically, what the story is with this, we had a ground loop built into the circuit board. So if you look here close, I made a cut here to isolate the power supply from over here, and another little cut right here to separate the preamp, the power amp, and the power supply. What I did to reground it was up here where the ground for the first jack is. I soldered a solder lug right here across the ground here for the first input jack, and across the trace on the board, and it goes into a screw in the chassis, and it's right here by the front of the amp. So we've grounded the preamp over here, the power amp is grounded over here, and the power supply. That cut down on our noise tremendously. If you remember, this thing sounded with the volume turned all the way off, where we have right now. Listen close. That's as loud as it is. Sounded like an electric razor before. Something else I did was, since this has a half-wave rectifier, just one diode, they take an awful lot of filtering. And this was a 33 microfarad filter underneath the board, so I actually paralleled another 47 on top of it here. This needs to see roughly about 100 microfarads to filter this. There's still some ripple in it, but we're leaving it. Like I say, this was a very inexpensive amp, and they left a lot of design issues in it. For those of you that run into this, we've talked about this bias thing. This board has been hot, but it's not conductive. But get your screen current down. Anyway, so you see where we are. So I'm going to button this little fella back up again. And hopefully the owner will be happy. This is just another one of those cases where I have to re-engineer stuff. This again is just one of the reasons I refer to this shop as the home of the daily unappreciated miracle. Most people have no idea what it takes to figure this stuff out. And in this case, with not a great result, because the amp, even after all this work, is still not a Fender champ by any means. So anyway, we'll get back together and fire it back up. Oh, something else I mentioned to you. I dropped out the bright cap here off the volume control. This thing was like fingernails on a blackboard. That kind of helped it a little bit. So we'll get back together and see what we've got. Okay, let's give you a quick run through here. Just let's see what's going on. I am so glad to have this thing back together. Every time I turned around, there was something like a, stripped, cross-threaded T-nut, or, anyway. It's just one of those things. This is another example of those days that you work and work and work, basically for nothing. So anyway, but it's done. So, and it can get off the bench and out of here. So, that's the low channel. We say this is a solid state front end. There's 2 transistors in the front of this, so the only tube in it is one EL84. And the tone control also does not work like any of the Fender stuff. This is different. Kind of passes highs a lot. And if that's not enough for you, here's the bright channel. That's bright. I also took the bright cap off the volume control. Actually made this usable. There's your tremolo. Again, there you go. Just a quick look at it. Just to give you an idea, 4 watts, Marshall's little made for mail order rarity. But there's been a lot done to get this amp up and running again. So until next time, play nice. I'll see you later.